So this is part 2 of our radical lesson, which is kind of new for a lot of us in grade 11. It's called Rationalizing the Denominator. Now these expressions that you see, they're in exact form. So somebody's saying, Mr. Jones, what are you talking about? Notice question 3, C. Sorry, question 6, example 6, question C. Negative 3 over root 5 plus 2. That's a possible answer. Basically in mathematics, we don't like radicals in the denominator. So this is a stylistic. Basically, it's bad form. It's like not correct. Okay? So we don't like it. So in other words, we're trying to get rid of the radicals in the denominator. But how do you do that? It's quite simple, and yet a little complicated for some of you. Basically, the way to get rid of those radicals in the denominator is multiply by 1. Or use conjugates. Some students don't know what that is, so don't worry. It'll make sense when we get to example C. Let's take a look at this one. Question A. This is 1 over root 2. So notice, really easy. A lot of you will see the pattern. This is root 2. So I want to get rid of the root 2. Notice, we don't like radicals in the denominator. It doesn't say anything about numerators. We can have radicals in numerators. So watch what I'm going to do. This is 1. Now notice some of you say, but Mr. Chen, you taught us in the rational expressions unit, don't we just start dividing? If we start dividing this root 2 and this root 2, we're going to go back to the same question. So that's, which is good, don't get me wrong, you're thinking about it, but that's not what we're trying to do here. Okay, and again, I was off screen here, but a lot of you realize I'm now going to use our traditional how to multiply fractions. 1 times root 2 is root 2. Root 2 times root 2, you know I'm going to be a little silly, ladies and gentlemen. That's root 4. And notice, under the radical sign, which is the radicand, this is a perfect number. The square root of 4 is 2. And there you have it, ladies and gentlemen. This has been rationalized. That's what they call it, rationalized. Notice in this answer, there's no more radicals in the denominator. Everyone see that? Pretty easy, right? But let's take a look at example B. This is 7 over 3 root 2. Now before you start going gung-ho and everything, I would recommend that you use the lowest common multiple kind in your head. So a good argument is, Mr. Chan, can't we use 3 root 2 over 3 root 2? We sure can, but then you'd have to reduce. So you know what we would do for this example? We would use root 2 root 2. So this one tends to be easy because, again, these are what's called monomials in the denominator. Monomials, only one term. What's our answer? Let's see if you can try it yourself at home. If you want, pause the video. But I think, let me know 7 root 2 is in the numerator. And notice what we're going to get 3 times root 4, without being a little silly, Mr. Chen. Seven root 2 over 6. Because the square root of 4 is 2, and again, notice that I'm emphasizing it's not addition, not like a mixed fraction. It's a mixed radical, which is multiplication. And this is the answer we're looking for. It looks totally different, everyone agree? But it's actually equivalent. And you can use your calculator, check to see the decimal answer or the approximate answer. So let's take a look at this one. And that is why, unfortunately, with example 4 and 5, which I did not really teach or go over, I think some of you should be able to figure this out. This example, we are going to multiply by 1, but not just any 1. If you look at this root 5 plus 2, and actually, I normally don't write it this way, but it's root 5 plus 2. We're going to use what's called its conjugate. Again, this is actually bad math. Is it okay if I change this question? The reason why most students actually like it this way, even though I was copying the question from the past. Most students like it like this. Okay? I'll explain it a little bit. Because the reason why, some of you might remember the quadratic formula, and the radical side is usually on the other side. So that's why I was trying to appeal to you. So it looks like that. But I'm going to do it this way. So I changed the question. It doesn't really matter, but What? So watch what I'm going to do, ladies and gentlemen. Look over here. We're going to multiply by a conjugate. Now, notice the conjugate is just simply the other sign. So, for example, if we have 2 plus root 5, its conjugate would be 2 minus root 5. It doesn't mean it's the same. That's its conjugate. And vice versa. If we had 3 minus root 7, what would its conjugate be? 3 plus root 7. Everyone see that? Watch what I'm going to do, though, ladies and gentlemen, as I do the 2 minus root 5 over 2 minus root 5. Oh, no, this is the idea. This is still 1, everyone agree? And some of you realize this particular pattern, that's why we're leaving question C, it's distributive property. So go slow for the numerator. Negative 3 times 2, negative 6. Negative 3 times negative root 5, that's positive 3 root 5. Everyone okay with that? So the numerator doesn't seem to be a problem for a lot of students. And if you look at example 4 and example 5, it'll make more sense. However, notice the denominator. This is, and again, I'm trying to do this properly, 2 plus root 5 times 2 minus root 5. Anyone seen an algebraic pattern that you've learned before? Maybe from algebra? Maybe if I change it to A plus B times A minus B. Anyone remember this? Can I give an idea?
Is it a difference of squares?
It is a difference of squares. Notice, and that's why I'm not trying to lie to you. That's why I try to teach my students in grade 10 and 11. And this pops over and over. Difference of squares happens over and over again. And notice what's happening here? It's kind of happening here, although they're numbers. But notice they're like algebra. So what's 2 squared? Because that's this. So that's 4. Difference, so minus. What's root 5 times root 5? Well, that's root 25. So we'll just do that now. But root 25 is 5. I see now why they questioned this, so it's my fault. It's too late now. Over negative 1. And some people don't like the negative. It's not always going to become negative 1. Let's just get rid of this. And in short, I should have left it the way that they had it. That's my fault. We would have gone positive. So that's my fault. So the answer is, if you got here, that's fine. And again, it's not always going to be like this simple, 4 minus 5. But if we factor out a negative, then the negative will work out. So then I think we get 6 minus 3 root 5. That's the answer we're looking for. And again, if I went too fast, watch. Let's just go a little bit slower for some people. I factor out a negative 1, so I get negative 6. Oh, I get 6 minus 3 root 5 over that negative 1. And those negative ones divide out. So I should have left it actually how the question was. I was over analyzing it, thinking that this is weird. Okay. This is called rationalizing. Have you guys seen this before, grade 10? Have you guys seen this? You should not have unless you're in enriched math. Okay. So that's called rationalizing.